Hello everyone, we are back with Ciphernoon. So we have Codecademy open, and today we're going to start on learning Python, which is really great because I am actually in the middle of working on this Steam Monsters game jam, and I'm using the RenPy game engine, which once we get past doing some beginning lessons, I think we're going to do a couple projects together. So you might see RenPy later on as a platform, but RenPy is run on Python, so it's always good to get the mind going and fresh. Today's the last day of the game jam, so wish me luck. Well, I mean, I guess future luck, because you'll see this after it's done, but, you know, whatever. Time's the lake. What are you gonna do? Okay, so let's get started. Python syntax. Hello world. If programming is the act of teaching a computer to have a conversation with a user, it would be most useful to first teach the computer how to speak. In Python, this is accomplished with the print statement. Print, hello world. Print, water. There is not a drop of water there. Were Niagara but a cataract of sand, would you travel your 1,000 miles to see it? I feel like that's some sort of, quote or something. A print statement is the easiest way to get your Python program to communicate with you. Being able to command this communication will be one of the most valuable tools in your programming toolbox. Use the print statement to output a message of your choosing to the terminal. Great, okay. So first thing, we notice that we have our console back, and it looks a little different than it did in HTML. So this right side won't pretend to be a browser. It'll just be as if it was the Python program running. And you can see this script.py here that tells you that this file is written in Python. That's what the .py means. Okay, so print. We're learning Python today. Okay, let's see. Ooh, so impressive and neat. Okay, print statements. There are two different Python versions. Both Python 2 and Python 3 are used throughout the globe. The most significant difference between the two is how you write a print statement. In Python 3, print has parentheses. Oh, this looks lovely. Deep into distant woodlands winds a mazy way, reaching to overlapping spurs of mountains bathed in their hillside blue. Wow, we got some poetry in this coding lesson this morning. Okay, so in this course we'll be using Python 2. If you go on to write Python 3, it will be useful to note this key difference. Okay, so print something using Python 3 syntax. Let's print, we love poetry in the morning, in the evening. Whoa, look, there it is. Awesome. Okay, next. Strings. When printing things in Python, we are supplying a text box that we want to be printed. Text in Python is considered a specific type of data called a string. A string, so named because there are a series of letters, numbers, or symbols connected in order, as if threaded together by string. Strings can be defined in different ways. This is a good string. You can use single quotes or double quotes for a string. Above we printed two things that are strings and then attempted to print two things that are not strings. While double quotes and single quotes are both acceptable ways to define a string needs to be opened and closed by the same kind of quote mark. Okay. We can combine multiple strings using plus, like so. The code will print out, this is a good string. Okay, so try adding your name to the print statement with the plus sign operator so that this Python program prints hello, your name. Okay, so this is the print statement they set up for us. So we're going to use the plus operator, and then we're going to put our name. Perfect. Handling errors. Python is wonderful for errors. Honestly, like, I remember when I first started doing HTML or CSS, like, if you F up, it just won't do the thing that you want it to do, and it won't tell you about it. And, you know, that makes a lot of sense, and in some ways, that's really good practice, because then you just have to sit and go through the code bit by bit. You'll have to do this anyways, but, like, you just have to get used to, like, patiently going through the code. But Python is really amazing in that it often tells you where your error is and tries to communicate why it's confused. This has been so helpful for me with the RenPy game engine, because it will literally tell me the line where I effed up and be like, there's no indentation here. I was expecting, you know, something. Handling errors. As we get more familiar with the Python programming language, we run into errors and exceptions. These are complaints that Python makes when it doesn't understand what you want it to do. Everyone runs into these issues, so it's a good habit to read and understand them. Here are some common errors that we might run into when printing strings. Print mismatched quotes will cause a syntax error. Print without quotes will cause a name error. If the quotes are mismatched in Python, so you have like a double quote and then you close it with a single quote like they have right here. See how it starts with a double quote and closes with a single quote. That's what they mean by if the quotes are mismatched. Python will notice this and inform you that your code has an error in its syntax because the line ended, called an EOL before the double quote that was supposed to close the string appeared. The program will abruptly stop running with the following message. Syntax error. EOL while scanning a string literal. This means that a string wasn't closed or wasn't closed with the same quote character that started it. Another issue you might run into is attempting to create a string without quotes at all. Python treats words not in quotes as commands, like the print statement. If it fails to recognize these words as defined in Python or by your program elsewhere, Python will complain the code has a name error. This means that Python found what it thinks is a command, but doesn't know what it means because it's not defined anywhere. We've written two print statements that will raise errors. One has mismatched quotes and the other has no quotes at all. Fix the two print statements to successfully debug the program. Okay, so here we'll fix you by making double quotations. Oh. This one, please. There we go. And we'll fix you by putting you into quotations as well. Yay! How do you make a hot dog stand? You take away his chair. That's great. Okay, we're gonna go next one. In Python, and when programming in general, we need to build systems for dealing with data that changes over time. That data could be the location of a plane, or the time of day, or the television show you're currently watching. The only important thing is that it may be different at different times. Python uses variables to define things that are subject to change. In the above example, we defined a variable called greeting message and set it equal to the string welcome to Codecademy. It also defined a variable called current exercise and set it equal to the number 5. Create a variable called today's date and assign a value that will represent today's date to that variable. Okay, so the variable, we're going to make today's underscore date like they asked us. Set it equal to, the date will be different for you, but for me. Oh, yeah, I was expecting it to print it, so I was like, where is it? Where is it in the little window here? But we didn't add a print statement, so it's just like, great, you did it. You're awesome. Carry on. Arithmetic. One thing computers are capable of doing exceptionally well is performing arithmetic. Addition, subtraction, multiplication, division, and other numeric calculations are easy to do in most programming languages, and Python is no exception. Some examples. Above are a number of arithmetic operations, each assigned to a variable. The variable will hold the final result of each operation. Combinations of arithmetical I don't know how you pronounce that. Hold on. Arithmetical. I'm gonna look for a thing that. Here we go. I want that. Arithmetic. So, arithmetical. I guess it's arithmetical because this tells me that this is arithmetic. Arithmetic. So, arithmetical. Operators follow the usual order of operations. So the order of operations is just when you were learning math. Maybe if you know, I don't know where you learned math, but when I was learning math in school, they would do the order of the operations. They would tell you which things to do first so that you would get the same answer every time in a string of a problem, like a string of math equations. Python also offers a companion to division called the modulo operator. The modulo operator is indicated by the percentage sign. Modulo? Let's see. Modulo? I don't know what this is. I want one of those handy sound things again. There we go. Modulo. Yeah, modulo. Okay, so the modulo operator is indicated by percentage sign and returns the remainder after division is performed. In the above code block, we use the modulo operator to find the remainder of 15 divided by 2. Since 15 is an odd number, the remainder is 1. We also check the remainder of 133 divided by 7. Since 133 divided by 7 has no remainder, 133 modulo 7 evaluates to 0. Okay, multiply two numbers together and assign the result to a variable called product. Okay, so we're going to do product as our variable, and we are going to multiply 13 times 4. Yes. Oh, we have more. Okay, so what is the remainder when 1,398 is divided by 11? Save the results in a variable called remainder. Great. Okay, so we're going to make our variable remainder, and it's going to be 1,398, and we'll use the modulo operator. Hold on. Did it like that? Yes. Yes, we did it right. Yes. Okay, updating variables. Changing the contents of a variable is one of the essential operations. As the flow of a program progresses, data should be updated to reflect changes that have happened. In the above example, we start with 50 fish in a local pond. After catching 10 fish, we update the number of fish in the pond to be the original number of fish in the pond minus the number of fish caught. At the end of this code block, the variable fish in Clark's pond is equal to 40. Updating a variable by adding or subtracting a number to the original contents of the variable has its own shorthand to make it faster and easier to read. That's this one right here, that plus equal and that minus equal. In the above example, we use the price of a sandwich to calculate sales tax. After calculating the tax, we add it to the total price of the sandwich. Okay, so we calculate the sales tax here, and then we add it to the price of the sandwich here, because it's the sandwich price, plus equals the sale tax. So that's the shorthand to take what's here, add that, and make that number the new content of that variable. Finally, we complete the transaction by reducing our money in wallet by the cost of the sandwich with tax. Right there, that's that last one. Okay, so we're trying to figure out how much it rained in the past year. Update the annual rainfall variable to include values from September to December. Okay, so let's take a look. They've provided a lot of stuff for us here. Okay, so they did the January. Okay. So I guess the best thing to do would be, okay, let's look at the code. Let's break down the code. So the January to June rainfall, so January, February, March, April, May, June, so those were all combined. And then so annual rainfall is the same as all of these things combined. And then there's July rainfall was there, and then annual rainfall is itself plus July rainfall. Perfect. And then August rainfall, and then annual rainfall is plus it's like itself, whatever number is that now, plus August rainfall, and that's returned to annual rainfall as a new number. And then they give us these 4 months. So I think we should do it the way that they've done it here. I think we should just start it off by adding all these together into a variable. We could do them, well, actually, you know what, honestly, we could do it either way. The other way we could do it is we could just add one of these under each of these, right? They've shown us 2 ways to do it. A way where you take it all together one time, you make it into one number, and you add it to annual rainfall, or month by month. So, let's just do it month by month. Okay, so for September, we're going to take the annual rainfall, and we want it to be itself plus September underscore rainfall. So we want it to be whatever it was here plus this 5.6. And then the same here. Annual rainfall is itself plus the value of October rainfall. Annual rainfall plus itself, and November rainfall. And then for December, annual rainfall plus itself, and December rainfall. Okay, let's see if it liked that. Perfect, yay, we did it. Next. Okay, comments. Most of the time, code should be written in a way that is easy to understand on its own. However, if you want to include a piece of information to explain a part of your code, you can use the £sign. What is that called? I always call it the £sign because that's what they used to call it when, like, on the telephone. I know, like, a lot of people call it the hashtag sign now, but this might be a little bit too intensive for right now. Yeah, we can't deal with that right now. I'll look it up later. I'm just going to call it the £sign. You might know it as the hashtag sign, depending on, you know, the life and different things. I've also heard it called the number sign as well. So I might call it that as well. But, you know, just know £sign, number sign. I'm talking about this guy right here. Okay, a line of text preceded by a pound sign is called a comment. The machine does not run this code. It is only for humans to read. When you look back at your code later, comments may help you figure out what it was intended to do. This is so important. I don't know if we've gotten into this yet. I don't care. We're going to get into it again. So when you're doing, I think we do get into this maybe in HTML, but when you're writing code for projects for yourself, you should use comments. When you're writing code for projects for other people, you should use comments. I have been so bad about this in the past, but ever since I started doing open source development, I am so thankful for the people who give really good readable comments, because they use it to communicate not only, how something works, but why they chose to do it the way that they did, and that's really important. We assume that programming and dev work and coding is always adhering to the same logic, but coders and programmers are just as creative as anyone else, and they often approach problems differently, very differently, depending on how their brain works, what makes the most sense to them, what they think makes the most sense with the language that they're using. And you're not automatically going to think the same way as another developer. So adding these comments and being able to read these comments really helps to be able to either go back to old work that you were doing and you dropped in the middle and you're just like, why did I do it that way? Or if you want to revive an old project, or you want to work on something that someone else did, or you're making something for someone else to work on. Comments, all the time. Hold me to that. Honestly, I hope that, I'm gonna have to really make sure my GitHub reflects this now. Comments all the time, because I talk about it. Okay. Add a comment above the declaration of city pop with a description of what you think this variable contains. So we're going to add this comment of, I believe that this is referring to the population of the city. Woo! It agrees with me. Okay. Variables can also hold numeric values. The simplest kind of number in Python is the integer, which is a whole number with no decimal point, right? 1, 10, -5, they're all whole numbers, they don't have decimal points. A number with a decimal point is called a float. You can define floats with numbers after the decimal point or by just including a decimal point at the end. So here's a float. There's a number after the decimal point. Here's a float. There's no number at the decimal point, but the program knows that it's a float because the decimal point is there. There's a -5.5 float. You can also define a float using scientific notation, with E indicating the power of 10. Ooh. Rockstar. Okay. You are going shopping. Let's make a grocery list so you can plan your budget. Store the number of cucumbers you want to buy in a variable called cucumbers. Make sure it's at least 1 and that is the appropriate data type. The store doesn't sell partial cucumbers, so basically they mean use an integer and not a float, because you're not going to buy 1.5 cucumbers from the store. So, how many cucumbers do I want to buy? I'm going to buy 5. I'm going to buy 5 cucumbers. Okay, so each cucumber costs 3.25 doubloons. Store the price per cucumber in a variable called price per cucumber. Okay, so price underscore per underscore cucumber equals 3.25. Oh, I have to run to the washroom. Hold on 1 second, I'll be right back. Okay, I am back. Where were we? Okay, so create a new variable called total cost, which is the product of how many cucumbers you're going to buy and the cost per cucumber. Okay, so total underscore cost equals cucumbers times price per cucumber. Awesome. Next, print out total cost. What data type is it? We're gonna find out. It's a float. Yeah, man, these are expensive cucumbers. Okay, two types of division. In Python 2, when we divide two integers, we get an integer as a result. When the quotient is a whole number, this works fine. However, if the number does not divide evenly, the result of the division is truncated into an integer. In other words, the quotient is rounded down to a whole number. This can be surprising when you expect to receive a decimal and you receive a rounded down integer. So the value of this one, even though, okay, so 7 divided by 2 is 3.5, but if you run it like this, the value of it will be 3, because it will round it down to a whole number, to an integer. To yield a float as a result instead, programmers often change either the numerator or the denominator, or both, to be a float. So the numerator is the first number, so here it's where they made it into a float. The denominator is the second one, that's where they made it into a float. Or here they made them both into floats. And all three of these will give you 3.5, which is the right answer. An alternate way is to use the float method, where you, I guess, encapsulate the here they've contained the 7, the numerator into the float here. Okay, so you have come home from the grocery store with 100 cucumbers to split amongst yourself and your 5 roommates, 6 people total. Create a variable called cucumbers that holds 100 and num underscore people that holds 6. Got it. Okay, so create a variable called whole cucumbers per person. That is the integer result, so we're not going to add any decimals, no floats, of dividing cucumbers by num people. Great. So far, like, honestly, so far we're like blazing through. I'm not making any mistakes yet, but you know, I've done this a bunch of times. However, that doesn't mean that I won't make mistakes, right? Like, you can do programming for a long time and still just make mistakes because you hadn't practiced the basics in a while, or you just weren't paying attention, or whatever. You're just having a moment. So fear not, you will have lots of opportunity to see me get really frustrated and confused. Okay, so you realize that the numbers don't divide evenly and you don't want to throw out the remaining cucumbers. Create a variable called float cucumbers per person that holds the float result of dividing cucumbers by num underscore people, and then print float cucumbers per person. Okay, so for here, I think what we'll try first, we'll see if it works, is we'll use the float statement. So float, and then I'll just encapsulate cucumbers in that. And let's see if that does what we want it to do. Great. Perfect. Okay, multi-line strings. We have seen how to define a string with a single quote and double quotes. If we want a string to span multiple lines, we can also use triple quotes, like I did here. Triple, triple. This address spans multiple lines and is still contained in one variable address string. When a string like this is not assigned to a variable, it works as a multi-line comment. This can be helpful as your code gets more complex. Oh, okay, so because it's not associated with a variable in here, this acts like a comment. cool. Okay, so create a variable called haiku and store this haiku as a multi-line string. So we'll just kind of go up there for a sec. So haiku, and then 1, 2, 3. And then, okay, so the old pond a frog jumps in. Plop. Okay, let's see. Oh, made a mistake. Okay, so I have a variable. Haiku. Interesting. I'm not sure why that's there. Okay, anyways. Haiku. Ooh. Let's see. Haiku equals, yeah, 1, 2, 3. It says your haiku was the old pond or comma, a frog jumps in, plop. Oh, weird. Okay. Let's just try it again. I'm not sure exactly what I'm doing wrong, but we're gonna find out. So haiku equals 1, 2, 3, and it says the old pond, a frog jumps in. Oh. And then I'm gonna go up here, check it against the sky. What am I doing? The old pond. Oh, well here I have a typo on that one. Let's see. Did I fix it? I guess that fixed it. I guess the second time I had a typo, I'm not sure what I was doing the first time, but awesome. Booleans! Sometimes we have a need for variables that are either true or false. This data type, which can only ever take one of two values, is called a Boolean. In Python, we define Booleans using the keywords true and false. A Boolean is actually a special case of an integer. A value of true corresponds to an integer value of 1 and will behave the same. A value of false corresponds to an integer value of 0. Someone has introduced themselves to you using comments in script.py. Read the comments and then create a variable called age is 12 and set it to be true or false depending on if this person's age is 12. Okay, so hi, I'm Maria and I live in script.py. Oh, you live in this file. Cool. Cool. I'm an expert Python coder. Very cool. I'm 21 years old and I plan to program cool stuff forever. That's awesome. Okay. Well, Maria, age is 12. Your age is not 12. Create a variable called name is Maria and set it to true or false depending on if this person's name is Maria. This person's name is Maria, so we're going to set it to true. I don't know what I did there. Okay. Create a variable called name is Maria and set it to be true or false when this person's name is Maria, so we're going to say true. Perfect. Yes. Yay. Okay, value error. Python automatically assigns a variable the appropriate data type based on the value it is given. A variable with the value 7 is an integer, 7 decimal point is a float, 7 in quotation marks is a string. Sometimes we want to convert variables to different data types. For example, if we wanted to print out an integer as part of a string, we want to convert that integer to a string first. We can do that using string, str, and parentheses. So here this would print, I am 13 years old. Similarly, if we have a string like 7, we want to perform an arithmetic operations on it, we must convert it to a numeric data type. We can do this using the int in parentheses. If you use int parentheses on a floating point number, it will round the number down. To preserve the decimal, you can use float parentheses. Cool. Instructions. Create a variable called product. Okay, product. That contains the result of multiplying the float value of 1 and 2. Okay, so I guess I'll just start by doing float underscore 1 plus float underscore 2. It might not be that simple, but it might be. Yeah, great. So create a string called big string. Big string that says the product was X. Okay, so the product was, and then we're gonna turn product into an integer, or a string, pardon me. So it's the str parentheses, yeah. And then we'll put product in there. Okay, let's see if that did it. Yes, it did. Awesome. So you can see here, you know, I did the first string, I put a space after here, and then I used that plus sign operator they told us about earlier. Okay, great. So far we've looked at print statements, how to create, modify, and use variables, arithmetic operators like addition, subtraction, division, and multiplication, how to use comments to make your code easy to understand, different data types, including strings, integers, floats, and booleans, converting between data types. Let's apply the... Oh man, I thought they were going to let us go. No, they have one more thing for us to do. Okay, so let's apply all the concepts you've learned one more time. Create a variable called skill underscore completed and set it equal to the string Python syntax. Awesome. Create a variable called exercises completed, set it equal to 13. Create another variable called points per exercise, set it equal. Actually, I want 13 to be not a string, but an integer, so I'm going to change that to an integer. Equal to 5, because I feel like we're going to be doing arithmetic with it. And then create a variable called point underscore total, set it equal to 100. Awesome. And then update point total to be what it was before. Okay, so point total will be what it was before, plus the result of multiplying exercises underscore completed times points per exercise. Right. Awesome. Okay, so add a comment above your declaration of points per exercise that says above here, add a comment and it says the amount of points for each exercise may change because points don't exist yet. Amount of points for each exercise may change because points don't exist yet. I think that maybe it doesn't want that space right ahead of it. Let's try that. Perfect. Okay, so print a string to the console that says I got X points with the value of point total for X's. Okay, so we're going to print a string I got, and we're going to give it a space, and then plus, and then we're going to string point underscore total, and then we're going to give it another space, points. So do you see what I did there? Like I did I got, right? And then space, and then the plus sign operator, because I'm going to take this variable and put it here. And then after that, I opened up another string. You know what I forgot here though? I forgot another plus sign, I think. I think I have to do that. Awesome. Oh, yes! Oh man, that was so good. Alright, so we have officially finished the first part of Learn Python. Let's go back to the console for a sec, because you remember like every time we finished like HTML, it was like, oh, you're done, like 33%. It literally took us like three lessons. Not with Python. We're at 5% of Python, which is like awesome and amazing, but it means we have a lot of work to do. So congratulations on your work today, and I will see you next time. Bye. Oh, make sure you practice. I'm gonna go practice now because I gotta finish that game chat.